The popular saying, "change is the only constant in life," rings particularly true in the realm of technology, where breakthroughs occur daily with the potential to bring about transformative effects, from artificial intelligence and biotechnology to renewable energy and quantum computing. The range of possibilities is vast and limitless. Join us in this video as we explore some of the most fascinating emerging technologies that are positioned to reshape the world as we presently know it. So kick back, unwind, and prepare to embark on a journey into the future with us. Ready? Let's dive in. Edge computing. Edge computing is a model of computing that distributes the processing and storage of data closer to its sources, thereby reducing bandwidth usage and response times. It capitalizes on the advanced computing capabilities of devices to enable nearly real-time predictive analysis and in-depth insights, offering a higher potential for innovation to enhance quality and value. Additionally, it allows for the workload to be distributed, taking advantage of upgrades in computing capacity with embedded intelligence in devices. Edge computing can impact operational processes and lead to improved responsiveness for employees, customers, and businesses. To ensure optimal utilization of devices, a significant proportion of processing must be transferred to the edge. Sun-powered chemistry. The use of various compounds to enhance human health and comfort often involves the use of fossil fuels, resulting in the release of carbon dioxide, extractive procedures, and climate change. However, a novel method harnesses the power of sunlight to convert waste carbon dioxide into these vital compounds. This approach offers the potential to reduce emissions in two ways: utilizing unwanted gas as a raw material and using solar energy instead of fossil fuels for production. This marks a significant first step towards developing solar refineries that produce valuable chemicals from waste gas. These platform molecules can serve as the foundation for creating a diverse range of products, including textiles, detergents, pharmaceuticals, and fertilizers. Remarkably, numerous startups are at the forefront of a new technique for converting carbon dioxide into valuable compounds, primarily by driving chemical reactions with energy. Although using electricity generated from fossil fuel combustion for powering the reactions would be less environmentally friendly, the use of photovoltaics could potentially overcome this drawback. Microneedles for painless injections and tests. The advent of tiny microneedles may usher in a new era of painless injections and blood testing, as these almost invisible needles can be used in the form of a patch or attached to a syringe to reduce pain by avoiding contact with nerve endings. Currently, numerous vaccine delivery methods using syringes and patches are available, with many more undergoing clinical trials for treating various conditions such as diabetes, neuropathic pain, and cancer. These devices offer a more efficient way of administering medications by delivering drugs directly into the epidermis or dermis, rather than relying on skin diffusion as traditional transdermal patches do. This year, a significant breakthrough has been achieved, as researchers developed a new approach to treating skin ailments, such as psoriasis, warts, and specific types of cancer by incorporating microneedles into a therapeutic cream or gel. Internet of Things, IoT. The emergence of the Internet of Things, IoT, is set to bring about significant transformations in various aspects of our world. This innovative technology has the potential to impact every aspect of our lives. In healthcare, IoT is already being utilized to develop remote patient monitoring systems, allowing doctors to monitor their patients' health from afar and detect potential health issues before they worsen. In the transportation industry, IoT is contributing to the creation of intelligent traffic systems that can optimize traffic flow and minimize congestion. Additionally, IoT is revolutionizing the home automation industry by facilitating the creation of smart homes that can be managed using a smartphone application or voice commands. However, it is essential to recognize and address the challenges and issues associated with IoT's implementation and growth to fully leverage its benefits while mitigating any negative effects. With thoughtful consideration and proactive measures, we can build a world in which IoT is used to enhance our quality of life, increase productivity, and advance toward a more sustainable future. Satellite constellation. A satellite constellation refers to a group of spacecraft that share the same design and functionality and are intended to operate in similar, complementary orbits under common control to achieve a shared objective. These constellations have various applications, including navigation and geodesy like GPS, Galileo, and GLONASS, satellite telecommunications like Iridium, and Earth observation like DMC and Planet Labs. Currently, companies are developing large-scale constellations in low Earth and mid-Earth orbits to provide global satellite internet or support the Internet of Things, enabling direct connections between devices and systems. By having thousands of individual units in low-altitude orbit, satellite constellations can significantly reduce signal latency, which is the time taken for signals to travel from a ground station providing internet to a satellite and then to a user, when ensuring high coverage levels, particularly in remote areas with limited ground infrastructure. With around 2,000 active satellites currently orbiting the Earth, the number of satellites could increase by tens of thousands in the coming decades due to projected satellite constellations. Satellite constellations have become an essential element of space-based resources that track a range of phenomena aimed at protecting lives and property. These constellations consist of space assets from multiple countries including Europe, Japan, India, Russia, China, and Korea. The information provided by these constellations is used both qualitatively in images and quantitatively in products derived from cloud properties, atmospheric humidity, and radiance, to predict the weather using numerical models on a synoptic and regional level. GPS-3 LMSS, a division of Lockheed Martin Space, has designed and built GPS-3, a communications satellite commissioned by the United States Air Force to maintain the Navstar Global Positioning System. The first 10 satellites of the GPS Block 3 program, previously known as Block 3A, are included in this initiative. The US Air Force has given the GPS-3 satellites nicknames for the first time. The inaugural satellite, Vespucci, was named after the Italian explorer Amerigo Vespucci, whose name was given to the continents of the Western Hemisphere by early cartographers. The second satellite, named Magellan, in honor of the Portuguese navigator Ferdinand Magellan, who led the first circumnavigation of the Earth. The third satellite, named Columbus, pays tribute to the Italian explorer and navigator Christopher Columbus. GPS-3 is expected to have a 15-year lifespan, which is double that of some current GPS satellites. It is predicted to be 3 times more precise than current GPS technology, reducing accuracy from 5 to 10 meters to 1 to 3 meters. The signal will also be more potent, allowing it to overcome interference. The GPS Block 3 initiative aims to improve signal reliability, accuracy, and integrity. Lower carbon cement. Annually, the production of cement, a crucial ingredient in concrete, requires the use of fossil fuels and results in around 8% of global CO2 emissions. With a total output of 4 billion tons, as urbanization quickens, this number is predicted to climb to 5 billion tons within the next 3 decades. To address this issue, both startups and researchers are concentrating on low-carbon alternatives such as modifying the composition of components used in the manufacturing process, employing carbon capture and storage technology to minimize emissions, and eliminating cement from concrete. Quantum sensing. The application of quantum sensing has the potential to make a wide range of possibilities a reality, including self-driving cars with the ability to see around bends and portable scanners capable of tracking brain activity. Quantum sensors utilize matter's quantum nature to achieve a high level of precision, often by utilizing the difference between the electrons in different energy states as a base unit. While many quantum sensing systems are currently sophisticated and expensive, efforts are underway to develop smaller, more affordable equivalents that could enable new applications. Whole genome synthesis. The advancements in technology used to produce genetic sequences that can be inserted into bacteria have resulted in larger quantities of genetic material and more extensive genome modifications. This breakthrough can aid in research into viral propagation mechanisms and help create vaccines and other therapies. Moreover, it can support the sustainable production of chemicals, fuels, and building materials from biomass or waste gases. Additionally, this technology can enable the creation of pathogen-resistant plants or the manipulation of our genome, which offers both potential misuse and solutions for genetic disorders in the future. Green hydrogen. Governments worldwide are committing to aggressive emission reduction targets, with green hydrogen becoming a commonly used term among world leaders. Professor Hongqi Sun from Edith Cowan University believes that green hydrogen is critical for future energy sustainability. However, significant challenges need to be addressed before achieving the green hydrogen goal. According to Professor Sun, while hydrogen is the most abundant element in the universe, it is usually found in combination with other elements, particularly oxygen, as part of water. Generating hydrogen on a large scale necessitates significant amounts of electricity, and hundreds of billions of dollars are being invested globally in finding a clean method of hydrogen production. Catalysts have enormous potential in ammonia production, which is an essential ingredient in fertilizers used in global food production. However, ammonia production has seen little change over the past century and is energy intensive, accounting for 2 to 3% of global CO2 emissions. These small catalysts have the potential to revolutionize the production of vital chemicals in a more sustainable and environmentally responsible way. Alright guys, that wraps up our video for today. If you enjoyed this video, please give us a thumbs up and subscribe to this channel for more. Thank you and goodbye.